Hi everyone, welcome to Shark AI. My name is Chandan Shashwat, and this video we are going to see the concepts of statistics, which later we will implement in ML and AI. So let's start. So first we are going to see mean, median, mode, and ranges. So this is also important, that mean, median, mode, and ranges. So you have given a data. So how will you find what is the mean, what is the median, what is the mode, and what is the range of the data? So we are going to see that. So what is mean? So mean is basically the average. Average means uh, it's sum of your data, okay, divided by the count of data. Okay, so this is your mean, the sum of your data divided by the count, how many numbers are there. So that is your mean. Median is just the middle value. Okay, middle value after sorting. Okay, so first we'll do the sorting, and then whatever comes in the middle we'll take that value. And if the middle value is not 1, suppose you have the even numbers, then the middle two values we will add and divide by 2, so that will be the median. And the mode is the most frequent value. Okay, mode is the most frequent value. And suppose there are two numbers which are most frequent, then we will be picking the first value, which will be find out by the algorithm. So that will be the most frequent value. So we'll see one by one. So let's say that I have the data x is equals to, suppose here 1 2 3 4 5. Okay, so let's take a small data only for better understanding. So what will be the mean of it? So mean is the sum of total numbers divided by the count of the number. So 5 plus 4 9, 9 plus 3 12, 12 plus 3 15, 15 divided by 1 2 3 4 5, 15 divided by 5, that is 3. So our mean will be 3. And what about the median? Median is the middle value. So middle value is 3 here, because we have total value 5, so the middle value is 3, so our median will be 3. And mode, since we do not have any most frequent value, so it will just pick the 1. Okay, but if you give here any repetitive number, suppose 5 I have given, so my mode will be 5. Okay, if in the place of 5 if I give here 1, then my mode will be 1. Okay, so let's see how to do this in the Python. So suppose my x is here, so there are different library for doing this. I'm just using here the statistics. You can also use SciPy. Okay, import statistics, and I'm just going to print here statistics dot mean of x. Okay, so let's see. So the mean, it is saying 3, as we have already calculated. And if you keep on adding number 6 7 7 8 9, and when we will execute, then it is coming 5.2. Okay, the sum of all these number divided by the count. Okay, now suppose for this x only, we are just trying to find the median. So let's, for better understanding, let's start with 5. Okay, so when I'm doing it the 5, it is coming as 3. So as we had already calculated, the 3 is the middle value, so it is coming as 3. Okay, so as soon as I add here the 6, So this is the even number. So where is my middle? So in the middle I have two values, 3 and 4. Okay, so that means it is going to add these two numbers and divide by 2. That is 3.3 plus 4, 7 divided by 2. That is 3.5. So it will come as 3.5. Okay, now as I have already written here that after sorting, okay, so if I give here 1, uh, let's say I'm giving here 2. Okay, so how many numbers are there here then? I have 7 numbers, and if you do this without sorting, what is your middle value? 4. Okay, but actually it a median we find after the sorting. So once you do the sorting, then I think the 3 will be in the middle. Okay, yeah, and you can see that 3 will be in the middle because after sorting, let's do that. Print x dot sort. So we'll get to know what is the sort. Okay. Hmm. Okay, actually it will not return anything. So x dot sort and just will print x here. Okay, yeah, so you can see 1 2 2 3 4 5. So after the sorting you can see my 3 is in the middle, so that's what it is printing. And if you try to find the median without sorting, then my 4 is middle. So but this is wrong. Okay, we have to always find after the sorting. Okay, now let's talk about the mode. So let's say I have these values and I'm just trying to find my mode here. Okay, so statistics dot mode of x. So you can see I don't have any repetitive number here, so it is just picking the first value and printing it. If I remove 1, then it will print 2 because there is no repetitive number. As soon as I give 2 here, now let's see that as soon as I give 3 here and I execute it, saying that the mode is 3 because 3 is occurring 2 times. Okay, if you add here 4 2 times, then 4 is coming 3 times though, so my mode will be 4. Okay, now suppose a situation where I have 2 times 3 and 2 times 4, then what it will do, it is just printing 3 because 3 is coming ahead of 4. So if I give 4 here and 3 here, and when I do this mode, so it is printing 4 because now 4 is coming first and 3 is coming after this. So whichever number will be found first, it will print that. Okay, so that is the mode. Now ranges. So range is basically your minimum value. Okay, uh, your maximum value minus minimum value. Okay, so this is the range. So if I have this data and I have to just find the range, then print max of x minus min of x. Okay, and when I print, it is printing 3 because the maximum value here is 5 and the minimum value here is 2. Okay, so this is the range of my data. Okay, so this is about the mean, median, mode and ranges. Now we'll try to understand the quartiles. So what is quartiles? So in statistics, a quartile is a type of quantile which divides the sorted data set into 4 equal groups. So suppose I have x is equals to 1 2 3, 4, 5, 6 and 7. Okay, so as I have already explained what is the median, so median is the sorted, in the sorted data, the middle value. So this is your median. Okay, and if I have to divide this data set into the 4 equal parts, then if I divide from the fourth, then it will be divided into the 2 equal parts, 3 values in this side and 3 values in this side. Again, if I draw a line going through the 2 and going through the 6, so what will happen? It will divide the data set into the 4 equal parts. If I have drawn a line here, here and here, so you can see that I have one element here, I have one element here, I have one element here, and I have one element here. So the whole data got divided into the equal size. Okay, so these are called the quartiles. So this is the 25% quartile, this is median, and this is 75% quartile. So this is very important because this will help us to understand the data. Okay, so if it this is 2, so I can say that 25% of data is less than 2 and 75% of the data is greater than 2. Okay, and median is 4, that means I can say that uh, my 50% of data is less than 4 and 50% of data is greater than 4. And same way I can say the third quartile, which is 75%, that means my 75% of data is less than 6 and 25% of data is greater than 7, greater than 6. So this is very important to understand your data by knowing this quartiles. Okay, so now let's see by another example. So the same applies as we have already seen in the mean, median and mode. So if you have the even records, like if I have given here the 4 again, so give it as 5. So as I have already explained that the median, so it's a even number, so median will be 4 plus 5 divided by 2, that is 4.5. So one line will be drawn here. Okay, this is the line, and you have 1 2 3 4 records on this side and 4 records will be in this side, and then your 25% will be 2 plus 3 divided by 2. One line will be here and in this side also. Actually when we yeah, and this will be when we are drawing the line here, 5 plus 6 by 2, one line will be here. Okay, so this way the whole data set will be divided. Okay, and this is called your if I remove this value, so as I explained you, so this one is called the 25% or the Q1, that is the first quartile or the lower quartile, and this one is called the third quartile or the 75%. Okay, or the upper quartile, you can also say that. So let's understand this. So as I have already explained you in the pandas about this hard data set, so I'm just importing this hard data set here, and we'll see that how it works. So okay, I have imported, so I'm just going to show you what is there in the data set. So you can see that I have here age, sex, chest pain, resting BP and all this. So you can write here dot describe. Okay, so describe will give you a 5 number summary. So in the 5 number, what it gives you is like you can see here, and it will describe will give the values only of the numerical columns. Okay, numerical and the float columns. So you can see here what is the count, what is the median of the mean of the value, standard deviation. We'll look after this, what is standard deviation, and then what is the minimum value, what is the maximum value. Yeah, and this one, what is the 25% which I was talking about. So you can see that 25% is 47, that means 25% of data is less than 47 and 75% of data is greater than 47, and median 50% is half of the data is less than 54 and half of the data is greater than 54. 75 is also the same. 75% of the data is less than 60 and 25% of data is greater than 60, and this is the maximum value. So this is basically used to understand the data. Okay, as a data scientist you should be very good for understanding the data, what your data is saying and how it is behaving. Okay. Let's draw a box plot, because I have told you in the matplotlib that box plot is also very important, which we will cover later. So now we are covering this box plot. So let's draw this box plot and understand that what is how the quartiles and the medium looks in the box plot. So I am just taking a number here, 6, 7, 8 and 9. Okay, and I have already imported here the numpy. Okay, I will just do that. Fig figure is equals to plt. Okay, I have to import matplotlib. So if you have not watched my matplotlib and seaborn video, please watch that for understanding these plots. Dot pyplot as plt, executed this. plt dot figure, and the size I am taking here, fixed size is equals to 10.7. Okay, plt dot box plot, I'm just passing here x, the data, and plt dot show. Okay, so this is basically my box plot. Okay, so you can see that this is my first quartile. So first quartile is coming around 3. This is my median, which is 5, and this is the third quartile, which is 7. So my value, this is the minimum value and this is the maximum value. So this is what the box plot says. So I have a image here. So if I execute it, so you can see here this is your lower quartile. As I told you, this is the upper quartile, this is the median value, this is the minimum value, this is the maximum value, and this is the range of your data. Okay, maximum, I mean the maximum data which it covers. So this is that, and this is called the interquartile range. Interquartile range is q3 minus q1. Okay, so here the interquartile range, if we have to find, then it is q3 minus q1. Why it is important? uh, let's see that why box plot is important and why IQR is important, interquartile range. So I have taken the number from 1 to 9. Suppose I have added a number here, the 20. So let's execute this. So you can see that my box plot is saying my median is here, the middle value, the minimum value, the maximum value, and this value is outside of my plot. That means it is an outlier. Outlier is something which you can say that which is not the data, which is not justifying your data. I mean, you can see here that my data, all the data lying between 1 to 9, okay, with a difference of 1, but this data is uh, something which is not looks part of this data. Okay, so these are called the outliers. I will separately take a session, because there are plenty of ways to track the outliers and remove the outliers and how to fix them. So I will take first. Yeah, I was just showing you that uh, how we decide the outliers in the box plot. So this is the way, and there are ways that how to find the outliers and remove them using the interquartile range. So I will tell them all these, but not in this session. So yeah, So now we will discuss about the variance and standard deviation. So what is variance? So variance is a measure of how data points differ from the mean. Okay, or a variance is measure of a how far a data point set of data point spread out from their mean value. Okay, so if I say, okay, first we'll go through the variance formula. So variance formula is variance is equals to, and we represent it by the sigma square. Okay, sum of I is equals to 1 to n and xi minus mu square by n. So you can see that if I have some values like 1 2 3 4 and 5, okay, so you can see that we are doing a minus from the mean value, okay, square by n. So this will be your variance for each of the data point. So if I calculate the mu here, so 5 9 for take 15 divided by 5, that is mu is coming as 3. So variance for each data point will be here like uh, first point 1 minus 3 square by total number of points 5. Okay, so this is your first one. Then second value will be 2 minus 3 square by 5. Okay, then third value will be uh, 3 minus 3 square by 5. Okay, so this point will lie on the mean. So if you try, if my mean is here mu, then this point will be 4 by 5. This point will be 1 by 5. So 1 by 5 and 4 by 5. So it's actually every point will be positive because we have this square here. So 4 by 5 and 1 by 5 will be somewhere here, 1 by 5, and then the third value will be here. Okay, then another value. So likewise we have all the values. So these are actually called the variance. Okay, so how far it is situated from the mean value, so that is called the variance. Also you have noticed that we have square here. Okay, so if your x value is suppose in the centimeter, okay, so you will be getting variance as a centimeter square. Okay, so that is the difference. So actually you mean will always be, you can say, in the centimeter. Okay, but your variance will be in the centimeter square. And there is something called standard deviation. So standard deviation is just we denote it as a sigma, and it is the square root of variance. Okay, so the formula of it will be like square root of x minus mu square by n, and absolutely the sum here I is equals to 1 to n, and actually this is I. So all the values will be variance value. This is, okay, square root of this. So the main difference between these two is in the variance you are getting uh, unit of measure as a square. Okay, and in the variance you are getting the absolute unit of measure. That is, if this is centimeter, then you are getting the centimeter here, but in the variance you will be getting the centimeter square. Okay, so these are the two differences. But yeah, we mostly take the standard deviation because it is the same the unit of measure uses. Also the sparsity, if I say the variance, so variance is actually a square, so standard deviation is coming here, then your variance will be somewhere here because this is the square, double of it. Okay, not actually double, but yeah, square of it. So if your another value is coming here, then definitely variance will be somewhere here. Okay, so this will be nearer values, and this is more sparse values, the variance. Okay, so now we are going to discuss about the Gaussian distribution. So Gaussian distribution is also known as a normal distribution, sometimes also referred as a bell curve. Okay, so what is it? So the normal distribution is continuous probability distribution that is symmetrical around its mean, and most of the observation cluster around the central peak. Okay, so that is the normal distribution. So how it looks is, uh, okay, so if I draw a Gaussian distribution, so it will be looking something like this. This side it will be your probability density function, density, and most of the, suppose this is your mean. So in one standard deviation, that is your mu plus one standard deviation, and mu minus sigma. So within this interval, our 68% of data comes. Okay, 68%. And within the two standard deviation, if I do this, mu plus 2 sigma, so within this, our 95% of data it covers within the two standard deviation, 95%. And within the three standard deviations, mu plus 3 sigma, and here mu plus 3 sigma, and in this interval it covers 99.7% of data. Okay, within three standard deviation. So this is our normal distribution or the Gaussian distribution, and also the bell curve, the same names. So as you can see that within the one standard deviation, it covers 68%. Within the two standard deviation, it covers 99%, 95%, and within the three standard deviation, it covers 99.7%. So this is also a way to find the outliers, that if it is not coming your in within the three standard deviation, and some point is referring here and some point is referring here, that can be also an outlier. Okay, so we will explicitly discuss all these things. So how it looks is, I have one image to show. So let's see that. So this is your probability density function. Okay, let me draw this probability density function. So the equation is y is equals to Gaussian distribution formula. We also say 1 by sigma square root of 2 pi and e to the power minus, this is x minus mu square by 2 sigma square. Okay, where your sigma is equals to a standard deviation, and mu is equals to mean. Okay, and pi 3.14, as you know, and e is equals to 2.7. Okay, so this is our formula for Gaussian distribution. So for each value of x, you can calculate the value of y, and similarly we have drawn here. Okay, so this is how we get our normal distribution. Okay, so if I see here, I can see the probability density function, and I can also see that 68% of data. So okay, let's not see this. First we will go through this image. So you can see that within the one standard deviation, it covers the 68.27 of 27% of data. So nearly equal to 68%. And within the two standard deviation, it covers the 95.45%. This is 95% we generally say, and then 99.73% within the three standard deviation. And I also explained you the box plot, so you can relate this with the box plot also, that within the interquartile range, it covers the 50% of the data. Okay, interquartile range, and you can see that it covers Q3 plus 1.5 IQR. IQR is basically your interquartile range. This one, Q3 minus Q1. So if you add in the quartile 3 with 1.5 and this value, then it will nearly give you the 3 standard deviations. Okay, within the 3 standard deviations, a little bit less, but that's okay. But it covers, yeah, within the 3 standard deviations. And up, you can see some points are here. Okay, in the box plot, this is the way of finding the outlier. So you can see these plots are here. These points are outside this Q3 plus 1.5 IQR. So these points are considered as outliers. And here also you can see that some points are in left side, which is Q1 minus 1.5 1.5 IQR. So this is the Q1, and this point is referring Q1 minus 1.5 IQR. Okay, so these points are also referred as outliers, and this is your IQR. Yeah, so this is about the normal distribution, and there is something called standard normal distribution. So it is also a type of normal distribution only, but uh, the definition wise, if we go, then it is uh, it has a mean as 0 and standard deviation as 1. Okay, the standard distribution is also called as a G distribution, is a spatial normal distribution where the mean is 0 and the standard deviation is 1. Okay, so if I draw here, okay, if I draw a standard normal distribution, okay, so suppose I'm drawing it. Okay, it's my bad. Okay, so if I drawing here, so our mean will be at 0 and standard deviation will be 1. Okay, 1. If it goes minus 1, actually it's 2, and here it will be minus 2. Here it's minus 3, and this side it will be 3. So this is your standard normal distribution. And how do we convert the normal distribution into a standard normal distribution is we have a formula called so if we draw the normal distribution, if we have a normal distribution here, okay, so here we have x, and here we have mu, and this is standard deviation, okay, mu minus sigma, and here it will be mu plus sigma, and likewise. So here we are drawing it with x. Now here we will take as a z, and what is z? So z is equals to x minus mu by sigma. So we convert all these values, okay, to a z value, and then we plot. And it got converted into the standard normal distribution, and mu is equals to your mean, and sigma is equals to standard deviation. Okay, let's talk about the central limit theorem. Okay, what is the central limit theorem? So central limit theorem says that the sampling distribution of the mean will always be normally distributed as long as the sample size is large enough. Okay, suppose you have a distribution. Okay, so let's say I have a distribution. Let's clear this. Okay, suppose my distribution is something like this. Okay, so what central limit theorem says is if you take a sample, suppose this is the 5,000 samples, and every time I am taking 100 samples from here, okay, and then plotting the mean, okay, in this 100 samples I will take a mean of it and then try to plot a graph here, then it will be normal distribution. Okay, so that is the central theorem says. Okay, so that is the same thing it says, the sampling distribution of the mean, the sampling distribution. So this is the distribution here, sampling distribution of the mean will always be normally distribution as long as the sample size is large enough. Okay, so when you take the 100 samples from here and draw the mean of it, then it will always be the normal distributed. So that is the central limit theorem. Okay, now another thing is that skewed data. Okay, let's see that. So normal distribution, we have seen that the it is very symmetric, but in the real data you will not be so lucky to get the symmetric curve every time. So let's understand what is right skewed, what is left skewed. So if I have something like this, okay, it goes here and then here and then here. Okay, and submit here. Okay, so you can see that these two graphs are not symmetric. It has a tail, this tail is on the left side and this tail is on the right side. So when your kurtosis, so this is called the kurtosis, so if your kurtosis shifts to the left or right, it is called the skewed. Okay, so here I can see it shifted in the right side, so this is the uh, left skewed and this is the right skewed, because we have skewness on the right side and here we have skewness on the left side. So and what will happen if your distribution shift to the left or right, then your mode will be here. Okay, then your median will shift to the somewhere here and your mean will be somewhere here. Okay, the same it goes here, so your mean will be somewhere here. Okay, your median will be somewhere here and your mode will be somewhere here. Okay, so this is the skewed one. So whenever we work with the real-time data, we will see that most of the time we got the skewness and we have to convert. So let's see how to draw this. So I have already imported this. Okay, and I already have this data. So if I go df dot head, this is the same data set I am using, which I used in the pandas tutorial. Okay, so if I just try to plot ax is equals to df dot cholesterol dot plot kde. Okay, plot dot kde. So I am just plotting this cholesterol as a normal distribution. Okay, so actually it's not a normal distribution. Okay, so you can see that we are getting the two humps here, bell kind of curve. So if I check the skewness of it, okay, you can also check the skewness dot cholesterol dot skew axis is equals to 0 and skip NA is equals to true. So if no value found, just keep those values. So skewness is saying that minus 0.61. Okay, so if anything greater than 0.5, you can consider it as a skewed one. And what are the ways for converting it to the because this is not a normal distribution, so some of the algorithm, like if you go to the linear regression, so linear regression says that data should be normally distributed. Okay, each of the continuous data should be normally distributed. So you have to convert this to the normal distribution. And how will you do that? So by using the cube root transformation, square root transformation, and the logarithmic transformation, by using all the techniques, we convert this data to a normal distribution. Okay, so that we will see when we will go to the algorithms and we will try to convert all these things, but not in now. Okay, so now we are going to talk about the sampling methods. So first we need to understand what is a population and what is sample. So first we are going to see what is population. So in statistics, population is the entire set of items from which you draw data for a statistical study. Okay, it can be a group of individual, a set of items, etc. So suppose you have a panda dataset of 1000 records. So in statistical language, the all this 1000 of records will be called as a population. Okay, and what is sample? So sample. So sample is an unbiased subset of the population that best represents the whole data. So sample is something which represents your population, okay, in a unbiased way. Okay, and when we need the sample, so it is used in statistical testing when the population size is too large. Okay, and it is impossible to include all the members of the population. Okay, so at that time we use the samples, not the whole population. So uh, how can I give you example for this, that population and sample? So you have many of you have already seen this, that exit polls are there. Okay, so whenever the voter comes out after the voting, then the two three people will be sitting representing the different channels, and they ask to each and every person that which party they voted for. Okay, and like this they do for some of the, they ask for some of the people and they create a sample. Okay, because it's not possible to ask to all the peoples whoever are voting. So they just collect a sample of it and they just try to understand that what is what will be the result of the population. So they just integrate it with the population. Okay, and just they just try to understand if sample is behaving like this, then what will be the behavior of the population. So that's why this population and samples are very important. Okay, now creating the sample is also very important. So how will you create these samples? Okay, so let's understand that there are many ways to create the samples. So the some of the methods are like random sampling. Okay, first one is random random sampling. So a random sampling, suppose I have this population. Okay, I have this, I have one group of people like this, another one is like this, and another one is like cross. Okay, another one is like minus minus minus. So here you can say random sampling means the creating a sample. Okay, and randomly we choose some of the data from here. So suppose I have chosen this 3, then this 2, this one, and I have not selected any of the negative one. So this is a sample, and this sample is called random because we have not done anything like for any rule based or something else. It's a complete random. Okay, if I have to select 1 2 3 4 5 6, so 6 I have selected, and that is the completely randomly I have selected, so it is called as the random sampling. Another method that is used is systematic sampling. Okay, systematic sampling. So systematic sampling is like I am selecting this one, then I am going next to this, Okay, then I'm just skipping this one and going here. Likewise, I'm selecting this one, skipping this one and going to this one. Then after this, I'm not selecting this one and going to this one. Likewise, this also. Okay, so this you can see that we are doing in a systematic manner. Okay, and whenever I select in my sample, okay, in my sample there will be 3 this one, 3 this one, 3 this one and 3 this one. So there is a systematic way of drawing the data. So this is called as systematic sampling. Okay, and it's a rule based. And another one is stratified. Okay, so what we can do, we can create a cluster of the data. So suppose I am creating, so I can see here that round datas are 5. So I have created a cluster, or you can see the strata of the data here. I have created another strata, this one a strata, and this one as a strata. Okay, and I am drawing two data from each strata. Okay, so suppose 2, this is 2, this is 2, and this is 2. So you can see that I am able to uh, take the data from each of the group, and you can see that I have all the data available. Okay, systematic drawing, it is possible that uh, if your data is, I have given this, then this, then this, then this, then something here, then here, then here, and then here. So if you go to the systematic sampling, you can see here that after 0 this is there, this is there, and this is there. And suppose this is plus here. Okay, and again a minus here. Okay, so after this there is this. So you can see that I have skipped this one minus here and this one minus here. So it is possible in the systematic sampling your all the observation will not come. Okay, but stratify means the creating the strata of the similar groups, and then it gives you the data from each of the strata. Okay, so this stratify is important because I remember I had given a data set when I was working for a company. So there I had an observation like one group of observation that was only 10. Okay, so if I would have been used the systematic sampling or this sampling, then that was not working. Okay, so what I did, I just did with the stratified sampling, and then my all the observation started coming into the my sample. Okay, so this is very important, and when I will teach you the linear regression or other algorithms, I will definitely show you this one, that how to handle this one in the ML. Okay, now the other thing is cluster sampling. Okay, that is the cluster sampling. So what cluster sampling is saying, that we have to create a cluster of the data. So there is a difference between strata and the cluster. Strata, you can see that I have just taken the similar kind of data together, but cluster is homogeneous data at the same time. Okay, I can say that if I have just represented the data here, suppose you have a data where the genders are defined. Okay, male and female, and their total earnings, and then they have their professions. So based on all these, okay, based on all this we create the clusters. So it may be possible that the clusters will be like this: these fours are similar, these fours are similar, and this is also similar, this is also similar. So taking all these, okay, in the sample, I'm drawing something from here, something from here, something from here. So this is called your uh, cluster sampling. Homogeneous set of data when we draw, then it is called uh, cluster sampling. Okay, so this is our sampling methods. Okay, and this will be, I will be showing you this one when we will be doing in the ML. Okay, and so these are the only important sampling techniques. Others are also there, but that is not required for us now. Okay, in the next video I'll try to cover everything left for the statistics, and then we'll go with the ML concepts. Okay, so there will be another video for statistics. Yeah, thanks for watching my video.